Oops. All right, so everybody got those. We talked about that one. Okay. We got x to the second. Okay, because we're subtracting. So in this case, we're right that there's an exponent of 1 there. So then we're going to look at our like bases. First of a. Okay. The rules when we're dividing the same base, we subtract the exponent, so we're going to get a to the first. Right? And it'll be b to the 8th. Right? And remember, we don't have to write the exponent of 1 on the a, so we can just simplify it as ab to the 8th. Okay. Dividing the same base, subtract the exponent.
Does it matter if you put a 1 or?
It doesn't matter. I wouldn't, but it doesn't matter. No. All right. So let's look at this one. X to the third divided by x to the second, all to the second power. Two different ways you could go about solving this problem. This would be a good one to have also. Okay. One way is we can go ahead and simplify what's inside this parenthesis first. If I do x to the third divided by x to the second, following our rule, what's that going to be? X to the first, right? Okay. And then if I take that to the second power, following our rule we did before, if I have a power to a power, what do I do to the exponents? Multiply them. So I would get x to the second. Okay. The other way we could have went about solving it was we could have taken this power to both the numerator and the denominator and got x to the 6th over x to the 4th, which we then subtract those exponents, we would get x to the second. Okay. Equivalent ways, order didn't matter in this case. Okay. That's what we got. All right. So in this case, y to the second divided by 4, all to the third. We're going to take that outside exponent, because we can't simplify what's on the parentheses any further, inside the parentheses. We'll take that outside exponent to both the numerator and the denominator. So the numerator is going to become y to the what? 6, because it's y to the second times y to the second times y to the second. It's y to the 6. We multiply those exponents. The denominator, remember that's like an exponent of 1. It's going to be 4 to the third, right, which when we simplify, 4 times 4 times 4, 64. So we'll get y to the 6th divided by 64. Okay. Dividing, we'll subtract the exponents. Here we just had to simplify. Oh, sorry, no, that's equal. Yeah. Equals y to the 6th divided by 64. All right. So, if we had a problem like this, following that rule, we would subtract 4 minus 4, and we would get x to the 0, right? But we know anything divided by itself, like x to the 4th divided by x to the 4th, or 10 divided by 10, or 5 divided by 5, or 100 divided by 100, is always what? 1. It's always 1, right? Because if I wrote this out longhand, x to the 4th, that's like x times x times x times x divided by the same thing. All of those divide out, and it equals 1. So up here I have x to the 0. Down here I have 1, but these are equivalent expressions. Okay? So what we get is anything that's to the 0 power is always 1. X to the 0 is 1. Y to the 0 is 1. Z to the 0 is 1. 10 to the 0 is 1. 100 to the 0 is 1. Anytime you get something to the 0 power, it's 1. Okay? It's not 0, it's 1. Because anything divided by itself is always 1. And if I follow that rule earlier, 4 minus 4 is 0. So anytime something comes out to be to the 0 power, the answer is 1. Okay? Not x to the first, because that would be, it'd have to be like x to the 5th over x to the 4th. Okay? Anything to the 0 power is always 1. Okay? So for example, y to the 0, like I said, is going to be 1. 9 to the 0 is going to be what? 1. Okay? Now, if you had this, all of this stuff, just following our rules from before, in parentheses, we'd have to take it to the 0 power, which is going to be 7 to the 0 times x to the 0 times y to the 0, which is all 1, but I still have that negative out front because I didn't have to take it to the 0 power. So in this case, it'd be negative 1. So just remember, you could have a negative out front, but anything to the 0 power It's always 1. So I could give you a big chunk in parentheses, and if it's all raised to the 0 power, always going to be 1. Okay. Anything to the 0 power is always 1. So let's review some integers here. Remember, any integer, any number, positive or negative whole numbers, remember integers, can be put on top of 1, just like when we were dealing with slope. If you have 4, if you need a denominator, you can always put it over 1. Remember, I'll explain why this is important in a second. Okay. But anytime you have a number, you can always put it divided by 1 because it's still the same number. You didn't change it. Right? Same thing with negative numbers. If you have negative 7, you could always put it over 1. Right? And it's still negative 7. Nothing changed. Okay. Same thing if you have variables. You can always put it divided by 1 and nothing changes. Okay. So it's important to know that if something's not a fraction, we can make it a fraction by putting it over 1, just like we do with slope. Okay. Because, same thing, if I have a coefficient in front, that can still be placed over 1. Right, everybody with me there? Any whole number or variable or coefficient variable, monomial, can be placed over 1. Okay. That's going to help us when we talk about negative exponents. Okay. Whenever we have negative exponents in an expression, we need to think about moving them and changing them. What I mean by that is anytime we move an exponent from either the top of the fraction to the bottom or from the bottom to the top, the exponent changes to a positive number. Okay? So anytime we take an exponent from the numerator and we bring it down to the denominator, it's going to become positive. Or if it's already negative in the denominator and we move it to the numerator, it's going to become positive there. So anytime you have a negative exponent, we move and we change it. You will never have an answer with a negative exponent, ever. Okay? Your final answer, or your final simplified answer, will never have a negative exponent. I'll show you how to get rid of them, and it's by moving it and changing it. Okay? We're going to move the exponent and change it. So, for example, if I have x to the negative 4th over y to the negative 9th, okay? Again, I never want a negative exponent. This will be a good one to have down probably. So I never want a negative exponent. These aren't the same base, so I can't just subtract the exponents. Okay. What I need to think about doing now is moving them and changing them. So what I'm going to do is I'm going to take this x to the negative 4th and I'm going to move it to the denominator. Because when you move it, it's going to make it a positive 4th power. And the same thing goes for the y. Since it's y to the negative 9th, when you move it to the other side of the fraction, it becomes positive. So these are equivalent expressions. But this is the one you would want to have simplified because it has positive exponents. We're okay with negative coefficients. We're okay with negative numbers out in front, but we will never have negative exponents. Whenever we do, we just move them to the other side of the fraction. It's much easier if I tell you what y and x are if it's positive exponents than if it's negative. All right, so for example here, in this case, I only have one negative exponent. I have x to the negative 3, right? So that's the only one that I need to get rid of. Okay? I need to move it and change the exponent. So I'm going to take that x to the negative 3 and move it to the bottom. Because then it's going to become x to the positive 3. Okay, by following our rule there. But the y is already positive, so do I need to move the y? No, it's already positive, so I'm just going to leave it there. Okay. Now the question is, what's left on top of the fraction? Okay. Is it a 0 or is it a 1? Okay. If it was a 0, 0 divided by anything is 0. And I don't know this equals 0. Okay. What we're left with up top is, if there's nothing, if we've moved everything down, we're left with a 1. Okay. It's kind of like we're dividing this by x to the negative 3, so we're left with 1. So whenever you move everything down, or if you happen to move everything up, you're left with a 1, not a 0. Because this isn't necessarily 0. If I put 0 here, it means the whole thing would be 0. So that would be my simplified solution. I have no more positive exponents, so I'm finished there. So, if I have 2 to the negative 4th, let's say I wanted you to simplify this in your head without doing anything. Okay? Without punching it into a calculator. Now, remember I said if it doesn't have a fraction, we can always put it over what number? We can always put it over 1, right? So we're going to put that over 1. Okay. Which then means I want to get rid of the negative exponent. So since it's in the numerator right now, I'm going to go ahead and move it to the denominator. So in the denominator, it'll be left with like 1 times 2 to the 4th, which will just be 2 to the 4th. And then since we'll say nothing, but there's really a 1, was left up top, we write a 1. So we can then simplify this 1 over 2 to the 4th, which is 1/16. So 2 to the negative 4th is equal to 1/16. Okay. I moved it to the denominator. I simplified 2 to the 4th, 2 times 2 times 2 times 2, to get the 16th. Okay. Everybody see how I got that? Okay with that? We never want negative exponents. We just move it to the other side of the fraction. All right, so if you have x to the negative 3, let's say that's your monomial right there, and you want to get rid of that negative exponent, we'll put it over 1 to start with, because there's no fraction. So then we'll just take that negative 3, x to the negative 3, move it to the bottom, which will leave me with 1 times x to the 3, so just x to the 3. Because we don't have to write this 1 times anymore. Right? So then on the top, I'll be left with 1. So x to the negative 3 is equal to 1 over x to the 3rd. Okay. Feeling okay with that? Yeah? Good. All right. So let's look at another example here. I want to give you a second to try this one first and see what you can do with it, and then we'll correct it and go over it together. I'll give you about a minute, minute and a half to try that. All right, so let's look at this. We need to raise everything to the negative 2nd power first. Okay, we have an outside exponent. So just like before, when we have a power to a power, what do we do to the powers? Multiply them. So 2 times negative 2 is negative 4. And 3 times negative 2, negative 6. Okay. So I've now got rid of the outside exponent, but remember our simplified solution can never have negative exponents in the answer. Whenever it does, I have to move them and change them. So this a to the negative 4th, I'm going to move to the denominator because that's going to make it a to the positive 4th. And the b to the negative 6, I'm going to move to the numerator, which will make it b to the positive 6. I can't go any further because I have different bases, a base of b and a base of a. So that's my simplified solution. Here, if I just have 7d to the negative 5, I'm okay with the 7 if I just want to simplify this monomial, but again, I have a negative exponent. So I can just put that, oops, let me go back here. I can just put that over 1, and all I need to do is move that to the denominator. So it'll leave me with 7 over d to the 5th. Then if I told you, okay, d is 3, you could plug in 3 for d, take it to the 5th power, take 7 divided by that number. So anytime you have negative exponent, move it and change it. This one, I have 2 divided by 5 times a to the negative 4th. So this part of the fraction, the 2/5, I can't simplify any further, right? 2/5 is simplified to 2/5. So I'm going to leave it how it is, but I have a negative exponent, so it needs to go to the numerator. So that means in top, I'm left with 2a to the positive 4th divided by 5, and that would be my solution. All right, how about this? I have x to the 4th over x to the 9th. Means I have 4x's being multiplied in the numerator, 9x's being multiplied in the denominator. Okay. We still follow our same rule that whenever we have the same base, we're going to subtract those numbers. Right? And whenever you subtract them, you put that answer in the numerator. 4 minus 9 is negative 5. But I don't want negative exponents. Right? So I need to put that over 1 and then move it. Okay? Which means I take this, move it to the denominator, I'm left with 1 up top, x to the 5th. Which makes sense because if I was to write this out by hand, I have 4 x's being multiplied there. Nine of them there. 4 of them would divide out to be 1, right? And I'd be left with 1 over x to the 5th, which is what I got over here. Okay. So that's visually how it would look if you wrote it out. But we can just follow our rules, subtract the exponents, move the negatives, and that's what we get. All right, so again, your final answer cannot have negative exponents. Anytime we do, we're going to move the negative exponents to the other side of the fraction in order to make them positive. Doesn't matter if you move them from the top to the bottom or the bottom to the top, the exponents will become positive. Just want to shot yourself first in your notes. Now this is putting it all together. Okay. I want to simplify these two monomials being multiplied together. So I'll give you a minute to try that. All right. So we have no outside exponents. So we can just start multiplying because this is all one multiplication problem. We can multiply the coefficients together. That gives us negative 6. A to the first times a to the negative third. So what do we do to those exponents when we're multiplying the same base? We add them. So if you have 1 plus negative 3, you're going to have a to the negative 2. And then we have b to the negative 4th times b to the 7th. Same thing. We're going to add the exponents when we're multiplying the same base. So that's going to give us b to the 3rd. Right? Okay. So now the only thing I don't like about this simplified solution is the negative 2 on that exponent. I'm okay with the negative 6. We can't change that. But negative exponents we can change by moving it to the denominator. And since there isn't one, we'll put it over 1. So we're just going to take that, move it down. So that's going to leave us with negative 6b to the 3rd over a to the 2nd. And that would be our simplified solution.
Because the negative 6 can stay up there, can't it?
Right, the negative 6 can stay up there. We're okay with negative integers. We are not okay with negative exponents. All right, this is the last one I'd like you to try in your notes, and then we'll move on to an iPad activity after this last notes one. So give this a shot, and then we'll come back together in a second. We can look at the coefficients. That's just like 4/6, right? So we can just simplify that fraction, which what does 4/6 simplify to? 2/3. Because both of those numbers are divisible by 2, right? Then we can look at our a variables. Whenever we are dividing things of the same base, what do we do to the exponents? Subtract them. So we have negative 2 minus 5, which is negative 7. Remember, anytime we subtract them, we always write the answer in the numerator. And then we'll move on to our variable b. b to the 5th over b to the 2nd. Subtract those exponents. B to the 3rd. So what's the only part of this answer we need to simplify? The a to the negative 7. We would like to move that to the bottom to become positive 7. So we're left with 2 b to the 3rd divided by 3 a to the positive 7. And that would be our simplified expression.